This is Algebra 2. I think it's Algebra 2. I can't even remember. But this question is about end behavior and how many times it crosses the x-axis and the zeros and so forth. And here's a nice table that helps. You look at the leading coefficient, whatever the variable is to the largest power. And if it's odd, like 1, 3, 5, 7, and then if the leading coefficient is positive, it starts from negative infinity and it ends up going towards infinity, and so forth. If it's odd negative leading coefficient, starts from the top and ends up going to the bottom. Starts from infinity, goes to infinity as the function goes to the right forever. If it's even, 2, 4, 6, 8, and positive, they both go up. If it's even, 2, 4, 6, 8, negative, both go down. And this is good too. If the multiplicity is 1, it crosses the x-axis. If it's 2, it bounces. 3, 5, 7, 9, it starts getting kind of flattened. And then 2, 4, 6, 8, 10, 12 starts even, it starts getting flat. So let's see. Let's do a few of these. I'm going to start with this one, and then I'll go to the other page. What is the end behavior of this polynomial? Now you got to watch out, because in standard form, I'm supposed to have whatever the degree is, that variable to the highest power all the way to the left. But here I don't. The degree is odd, and this is a negative leading coefficient. So this is as x goes to negative infinity, it means where does it come from? And then as x goes to infinity, where's it going? So I'm just going to look on my table. Negative, odd, up, down. So infinity, negative infinity. So that's all I write here, infinity, and it ends up going towards negative infinity. Next one. This one they've written properly. The degree is even. The largest power of the degree is right at the front, even and positive. So I'm going to look for positive, even on the table. Positive, even, up, up, both infinity. I go down to the next one. Here's the degree, 40th, so that's even and negative. Negative, even, down, down, both to negative infinity. Negative infinity, negative infinity. And then this one, the highest degree is 35, that's odd and positive. So positive, odd, positive, odd. You have to memorize this table. Down, up, negative infinity. I don't have it memorized, infinity. So that's the answer for those. Now, I'm going to go to this first page, and let's see what's going on here. I have to graph these. It says there are 3 distinct real zeros, and this is a cubic function. 1 to 6 are cubic functions and a positive leading coefficient. So that's odd and positive. So odd and positive, according to the table, odd positive, it's going to start from down and end up. So it's going to go like that. Start from down and end up. And I need 3 real zeros, 3 distinct real zeros. 1, 2, 3. It's going to go like that, like that, like that. That's it. 1, 2, 3. It's cubic. Starts from down, goes up, because it's positive and odd. Positive, odd, down, up. Let me try this one. 0 of multiplicity 2 and a negative leading coefficient. Well, it's still a cubic function, so it's odd. And I'm going to put 3 so I know it's cubic. And it's negative. So negative, odd, it's up, down. So it's going to start from up and end up going down. And now I need a 0 of multiplicity 2, so that's 1, 2, and there's one other. So when it hits that 0, it's going to bounce. And then it's going to go through like that and go down. So up, starts from up, negative, odd. Oh, wait a minute. Negative, odd, starts from up, ends up down. And I know it bounces because of that multiplicity of 2. At 0, it bounces. If it was 4, it would get flat. It would look more like that. And then if it was 6, it'd go like that. More. Okay. Let's see. I'm going to try number 4. No real zeros, negative leading coefficient. So this is still 1 through 6 are all cubic. So it's degree 3, which is odd. And it's negative leading coefficient. Negative, odd, is starts from up, goes down, and this says no real zeros. That means it never crosses the x-axis. And how am I going to start from up and end up going to negative infinity without crossing the x-axis? So this one is impossible. Impossible. And then number 5, 4 distinct real zeros. Well, 1, 2, 3, 4. That's not a cubic function. Cubic function can only have 3 total zeros. So it has 3 real zeros, 1 real zero, 2 imaginary zeros. It can't have 4, so this one's impossible. And then you can do the rest of them yourself on this sheet if you have it. I'll just do one more. This is 4th degree, so that's even, positive. Even positive is up, up. So I'm just going to write it here so I remember up, up. And it says 4 distinct real zeros. 1, 2, 3, 4. So it goes like that. Sometimes it's got to go like that and that. So quartic to the 4th power are going to look somehow like W's. Let me try number 12. No real zeros, positive leading coefficient. So it's 4th, it's even and positive. Even, positive, up, up. Well, that's good. No real zeros. So it starts from up and it goes like that. Never crosses the x-axis. All right, there's that sheet. Now I'm going to go back to the other sheet that I had and back up here. And I'll just do 2 here. Well, I guess I'll do 13, 17, and then that's it. Okay, 5th degree. Hold on, let me get more. I don't like being on the edge. 5th degree with no real zeros and positive leading coefficient. Well, that's odd. These say quintic, so that's 5th degree. Odd, positive. So odd, positive has to go down and then up at the end. And it says with no real zeros and positive leading coefficient. Well, if it crosses the x-axis, it has to cross the x-axis to go from down to up. But that would give it a real zero, so that one's impossible. And now I'll do one more, this 8th degree, with exactly 2 distinct non-repeated zeros. That means it's going to go through at 2 places, but all the other ones, it's just going to bounce off. So I'm going to do this. I'm going to do 1, 2 reals, and then that leaves 6 more. I'm going to do this one, 6th. So it's 8th degree, that's even, and positive. I'll look at my table. Even, positive, it's up, up. So I'm going to go up. Well, start from up. And then it's got to bounce, because this one is even, but it's going to be real flat there. Real flat where it bounces off that one, because it's to the 6th power. So this is 1 power, and then this is 6 power, 6, 7, 8. So let me show you that on Desmos. I'll put x plus 2 times x plus 1 times x minus 3, and this one will be to the 6th power. So these are the 2 distinct ones, and this is going to be the one that's not distinct. I could put 3 that are degree 2, 2 that are degree 3, but I'm going to do it this way. So x plus 2 times x plus 1 times x minus 3 to the 6th. X plus 2, times x plus 1 times x minus 3 to the 6th. And you will see, let me go home here. There's a real flat. At x equal 3, it's real flat. And there's the minus 2 plus 1. And it's hard to see on Desmos that it's going up and up, but it is. But it's very hard to graph these on your TI-84 because they're so elongated that you have to go forever and ever up. And if you zoom out too much, then you can't tell where one line starts and the next ends. But anyway, you can at least see that bouncing and real flat at x equals 3. So that's a little bit of when you're given degrees, even, odd, and the leading zeros, and a couple of little bit of information about the zeros. You can graph a general shape for these things. Sometimes it's more than one, as well as what is end behavior of different examples.